Welcome, I'm Giulia Rinaldi. In this video, I will present the software demo described in the paper. As we start, this page serves as the home page. The first task is to create a new project, so let's get started. In this phase, we define the title, for example, Pipeline DR DNN, and a short description. This pipeline replicates the configuration proposed by Theodorakos et al. 2023, and we save it. In the project overview, we can see the project entry. Clicking the title, we can read the description. In the status, we can activate or deactivate the project. Here, we can visualize the pipeline. At this moment, all the blocks are active and not configured. This pipeline was proposed by Theodorakos et al. And has two layers. The first one is called decomposition residuals, and it decomposes the signals starting from raw data to extract more information. The second layer is the nonlinear layer, containing the block with the model. The pink blocks are the input blocks. The orange blocks are the output and will be used to visualize the results after the pipeline training. Under the configuration column, it is possible to go directly to the configuration space. The airflow view is missing because it will be available when the service has started running the pipeline. Finally, clicking here when they are ready allows the visualization of the results. For time convenience, I have already created the other pipeline proposed in the paper, which skips the composition residuals layer. Now, let's go to configure the pipeline. Welcome to the configuration space. Here, we can activate or deactivate blocks and configure them with the parameters. So, here we have the pipeline. Each tab represents a block. The user can also navigate the pipeline by clicking directly on the blocks. Under each tab, the user can be guided by a short description and a suggestion with the parameters proposed by the designer. So, let's start with the endogenous signals. A little note, for obvious reasons, the only blocks that cannot be deactivated are the endogenous signals block and the DNN model block. As the description says, the endogenous signals are the variables to predict. In this example, the signal is the power load. The first thing to do is to select the dataset. In this software demo, the one available is the day I had electricity demand forecasting post-COVID paradigm. This is the snapshot of the data frame. The next step is to decide on the division of the dataset for further analysis. So 70% of the dataset will be used to train the model, 20% will be used to validate it, and 10% will be used to test its accuracy. The last part defines the endogenous signal as we send the power load and the index column, so the time. Additionally, we are using normalized data. The second block is the exogenous signals, representing the extra information to feed into the model. It is possible to select all or a subset of variables. We are going to select all. The third block is the robust signal decomposition, which decomposes the signals into three distinct signals. We can opt for the robust or weak version and define the period. For example, it is 7 days. The lambda parameters block uses statistical tests to decide the parameters for the following blocks. We can determine which test to perform, and each test is described here. Since we are going to define the parameters, we are going to deactivate this block. The following block is the moving filter. As we can see here, it depends on the lambda block. If the previous block is active, we can decide to overwrite the result by clicking this block and defining Q. In this case, the system will immediately use our definition. So Q is, for example, 2. It's the same story for the lags, where the parameters is 1, and also for the differencing, where the interval proposed is 0. No parameters are needed for the time signal block, so the user can decide only whether to keep the block active. The Deep Neural Network (DNN) model is the last block to configure. In this software demo, the only model included was the long short-term memory (LSTM) model. The parameters to define are the hidden size 64, output size 1, batch size 32, learning rate 0.001, and number of epochs 20. When all the configuration is done, the pipeline is ready to be sent to deploy. So, after the configuration is done, the pipeline can be sent to the external service Airflow through this button. After 4 minutes, under the Airflow column, it's possible to visualize the deployment page on the Airflow server. Here we can see the time used to run the pipeline. For example, DRDNN used 2 minutes and 17 seconds. Instead, the other pipeline, so without the decomposition residuals, use 1 minute and 55 seconds. Now that the training and testing have finished, the results can be visualized here. Each tab and block contain the summary of the configuration, except for the output blocks, colored in orange as mentioned previously. In the time signal analysis, it is possible to download the dataset with the extra signals extracted by the decomposition residuals layer. It is also possible to visualize a snapshot and observe the description of the data frame. Then, this block offers the visualization of plots related to the features and other signals, such as a calendar or wind. The second output block is related to Shapley additive explanations, and shows plot that explains the model better. The first plot shows the 20 most important variables, and the other 2 plots depict the feature impact for model 0 and model 23. The last block concerns forecasting. Here, the model and the prediction can be downloaded. The model's behavior can also be observed with a simple plot. The last area of the software demo to explore is the comparison space. Here it is possible to compare two pipelines, for example, the DRDNN design now and the pipeline without the decomposition residuals layer. Under this first tab, the two pipelines can be compared, and under the next tab, the results can be compared. Firstly, there is the model hyperparameters comparison. Then it is possible to select two dates and investigate the model prediction in different time slots. For example, 28th of September at 6 p.m. and 29th of September at 2 a.m. The predictions are compared with the expected values represented by the green line. The second plot shows the residuals plot, and the final table contains additional computations that are useful for comparison. To conclude, this video showed the functionalities of the software demo based on the DSX4X framework. It was shown how to create a new project, configure the pipeline proposed by Theodorakos et al., and run it in an external service. Moreover, the DSS supports the user with descriptions and suggestions. The model and predictions can be also downloaded for further analysis. Finally, the user can also compare pipelines together to analyze their behavior. Thank you for watching.